Hello, Integrated Math 1. Welcome to Lesson 2, Topic 2, Module 2, Topic 2, Lesson 2. It's a lot of twos. And we're on day 1 of this lesson because it's a bit much to cover all in one day. And we still have a lot we got to do just today, but we can manage this. So we're going to start off with activity 2.1 on page M2-111. We're going to be talking about literal equations today. And before we get too far into that, we're just going to review a little bit with a little bit extra from our last unit that we did before the break. So we want to talk real quick about equations in different forms. Remember how we had general form of a linear function, but we also had the factored form of a linear function, right? All that good stuff. If you need a little boost of a reminder on that, you can always flip over to page M2-35 in your workbook. In the little green boxes, it has some reminders about the general form of the function, the factored form of the function. It'll jog your memory when you see it. Now, of course, the reason for these different forms is they showed us different stuff, right? We had the slope, you can find the x-intercept, the y-intercept. These are all important characteristics of linear functions, right? Your slope is important. The x-intercept tells you where it touches your x-axis or where y equals 0. The y-intercept tells you where it touches your y-axis or where x equals 0. And they are each important characteristics of our linear functions. And the structure of our equations can reveal the characteristics of a function. You know this, you've done this before. So we'll start with the basics, shall we? Let's start with the basics. So let's consider the equation y equals negative 2/3 x plus 4. This should look like a very familiar form to you from last unit. And what I'd like you to do is, using this equation, I would like you to determine each of these special characteristics and, explain your work, show you got there, all that good stuff. So I want you to find the slope, I want you to find the y-intercept, and I want you to find the x-intercept. And that one might be a little bit more tricky. But go ahead and hit pause, see what you can do to find all of these, and then hit play when you're ready to check your work. So I don't know about you, but I noticed that this was in standard form. Did you catch that? This is totally in standard form, right? The whole y equals mx plus b. Is this ringing a bell? I think we also referred to it in the last unit as like y equals ax plus b. But the point is that this number stuck to your x is your slope. So my slope is negative 2/3. That's the number stuck to my x, so that's totally going to be my slope. And then, of course, this number hanging off the end, this b value, was our y-intercept. We know we've done this a million times before. So it looks like for this equation, my y-intercept is 4. So I suspect that you got those two pretty quickly. But the x-intercept was trickier to get. Now, remember how we said that for x-intercept, that's when y equals 0? So I can take this equation, y equals negative 2/3 x plus 4, and instead of a y, we can plug in a 0. And look, lo and behold, this now looks an awful lot like what we were doing in the last lessons, right? In the last couple of lessons that we were working on, how we solved an equation for x. We can totally solve this for x. If you want, you can make a big line down the middle. Some people like to do that. You don't have to. But now I can see x is over here. Let's get rid of that 4 first. It's a plus 4, so I'm going to go ahead and subtract 4 from both sides. And those cancel out. That's why we did it. So 0 minus 4 is negative 4. Still have an equal sign. Still have the negative 2/3 x. But now those 4s are gone, which is why we did it. I need to get rid of that negative 2/3. Do you know the trick on that? That you can get rid of a fraction by multiplying by its reciprocal? Do you know that trick? So the reciprocal of negative 2/3 would be negative 3/2. So let's multiply both sides by negative 3/2. Because of course, you know how this works, properties of equality. You do it to one side, you must do it to the other. We got to be fair here, have to be fair. Negative times a negative is a positive, so that makes things better. And the 2's cancel out, and the 3's cancel out. Oh, so I just have x, which is why I did it. Over here, let's take a look. Negative times a negative also gives us a positive. And we've talked about this trick before, how you multiply with the top and you divide with the bottom. So 3 times 4 gives me 12, but I'm going to divide out the bottom, which is 2. We can do 12 divided by 2, or you can use a calculator if you have to. 12 divided by 2 is 6. So it looks like my x-intercept is in fact, ooh, watch out for the mess, is in fact 6. Yay. All right, what about this one? I would like you to now consider this equation. Y equals 4 times the difference of x and 2. I'd like you, again, determine each characteristic. How'd you get it? So slope, y-intercept, x-intercept. This one's a little bit different than the last one. So see what you can do with it. See if it jogs a few memories there. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. So I'm going to take a look here. This is not standard form, or pardon me, general form. This is not general form of a linear equation, is it? But if you remember, again, you can always flip back to page M2-35. Remember how we said there were other forms? Do you remember factored form? Yeah, you remember factored form? That was the whole y equals a times x minus c. So it also had the slope, right? I've still got the slope, that's still there. The minus sign is part of the equation, but that guy after the minus sign, that's your x-intercept. Do you remember this? It's been a while. It's been a while since we did this. This was like way, way back in that other unit. But we've done this before. So this means, looking at this equation, I know my slope is 4. Easy peasy, lemon squeezy. Oh, but I don't have my y-intercept this time. Factored form gives me my x-intercept. So here we have this lovely little guy. The minus is part of the equation. So it's whatever's after the minus sign. It looks like my x-intercept then is 2. That's where it's going to hit my x-axis. But it does not give me my y-intercept. But you remember, you know how to do this. If you're finding a y-intercept, that just means, hey, x has to equal 0. So fine, instead of y equals 4 times x minus 2, let's plug in a 0 for x. Y equals 4 times 0 minus 2. And now it's actually pretty easy, right? Do your parentheses first. 0 minus 2 is a negative 2. And of course, 4 times a negative 2 is a negative 8. Hooray! So it looks like my y-intercept is negative 8. Good job, us. Yeah. So that wasn't too terrible. It wasn't too terrible. And especially if you remember that trick, that factored form gives you the slope and the x-intercept, it actually wasn't too shabby at all. However, there is one other form of equations that we do here. Slope, pardon me, we'll get there in a second. So I'd like you to consider this equation. We have not seen this form before. This is a new form for us. So we've seen general form, we've seen factored form. This guy's new. It's new. So here we have 3x minus 2y equals 8. Believe it or not, this is a linear function. It is. It's a linear function. It just doesn't look like what we've dealt with in the past, does it? But we still need to determine the slope, the y-intercept, and the x-intercept. So there's still work we got to do here. I might suggest to you that the easiest way to find these first two would be to get the y alone. I'll leave that with you as a hint. See if you can get the y alone, because I think that'll help you out a little bit. Go ahead and hit pause, see if you can get the y alone and find all of these pieces, and then hit play when you're ready to check your work. All right, shall we see what we can do here, people? Let's see what we can do. So I'm going to take this guy, 3x minus 2y equals 8. And we said that if we could get the y alone, right, get it a whole y equals mx plus b. If I can get the y alone, then I can find my slope, I can find my y-intercept. So I'm going to start off with that. I'm going to make a line down the middle. Makes things better. So let's see what we can do here. If I do 3x minus 2y, I need the x on the other side because y should be the only thing over here. So because it may be a negative 2y, but notice it's a positive 3x. So I need to subtract 3x. And you know the rules. If you do it to one side, you must do it to the other. So I'm going to do that. Those cancel out. And now I have a negative 2y equals. Now I do like the x to be in front. So I'm going to write this as negative 3x. And because that's a positive 8, I'm going to put plus 8. Ooh, I don't like that. Don't do that, little pen. Why do you do that, little pen? Don't do that. Better. So now I have negative 2y equals negative 3x plus 8. Already, this is feeling a little better. But of course, y needs to be totally alone. I don't want negative 2 times y. I just want y. So since that's negative 2 times y, I'm going to undo it by dividing by negative 2. But that means you have to do it to everybody. Everybody gets divided by a negative 2. Those cancel out. That's why we did it. So y equals. These do not cancel out. So let's just clean it up a little bit. Negative divided by a negative will make that a positive 3/2 x. And I suppose if you wanted to, you could write that as a decimal. But we usually like to have our slopes as fractions. We don't like decimal slopes. We like fractiony slopes. And positive 8 divided by a negative 2 gives us a negative 4. Oh my gosh, that looks so much better. Check it out, because now I know my slope is 3/2. Now I know that my y-intercept is negative 4. Hooray! There's still a problem though, right? Because I still need to find the x-intercept. I suppose if I wanted to, I could write this in factored form. Do you remember how we wrote this in factored form? Do you remember how we got from general form to factored form? Remember how you could divide out that 3/2, divide out that 3/2, right? So you got y equals, and we factored out the 3/2. I shouldn't say divide, but we factored out the 3/2. My pen back. So 3/2 goes outside, and then we're going to put our leftovers inside. So those cancel out, which gives us an x. I need to do some work over here. So negative 4, I don't like to divide by fractions. We multiply by the reciprocal, which in this case is 2/3. And remember how this works. We multiply the tops together, so that's a negative 8. And then we divide out the 3. So I'm just going to put negative 8/3. I'm going to leave it as a fraction. Oh, which means my y-intercept, right? Y equals a times x minus c. My y-intercept is whatever's behind the minus sign. So it looks like my y-intercept is 8/3. Pardon me, my x-intercept. I got that. My x-intercept is 8/3. Again, don't take the negative with you. The negative is showing you where your x-intercept is, but don't take it with you. It's part of the formula. Wow. All right, that got a little intense, but we made it. We managed it. We got there. It was a little intense, but we got there. I also want to point out this isn't the only way to find the x-intercept. You could plug in zeros, right? Plug in a 0 for x to help you find the y-intercept. Plug in a 0 for y to help you find the x-intercept. There are ways of doing this. You didn't have to go to factored form. I just went to factored form because I wanted to practice factored form. It's fine. So we have 3 useful forms for linear equations. Some of them are more useful than others. I mean, right? Because some of them they do better than others. So the general form we know, y equals ax plus b. I have my slope, I have my y-intercept. Factored form we've seen before as well. Y equals a times x minus c. A is my slope. That c after the minus sign, that's my x-intercept. And then we have the new guy. So this new guy was that last one we did, and it's called standard form, ax plus by equals c. I want to point out that there are some constraints on standard form, so watch out for that. A must be a positive integer. That when you do standard form, this number in front of your x sitting out the front needs to be positive. We do like that to be positive. And I'm also going to point out that while A or B could be 0, you can't have both of them be 0. Otherwise, it's not a linear function anymore. It doesn't work. So these are our 3 forms of our functions. They're very useful. So I would like you just take a moment, glance at these guys here on number 4 on page 112. I would like you to identify the form for each one. Is it general form? Is it factored form? Is it standard form? Which one is it? Go ahead and jot it down, hit pause. So these are 3 equations from before. So go ahead and hit pause, jot down which form each of these is, and then hit play when you're ready to check your work. So I suspect you did these quick. This has y equals negative 2/3 x plus 4, no parentheses in the y's alone. Psh, that guy is general form for sure. This second one also has the y alone. It has a y equals, but I've got parentheses here now. So that tells me that chunk of parentheses with the minus and all that jazz, that's factored form. It's totally factored form. And this lovely guy right here, where my x and y are on the same side, where I've got a positive number out in front and there's no fractions or anything like that, that tells me we're in standard form. So each of these forms is great, but can you take a moment and consider how each of these forms can help us out? Standard form, did standard form feel not helpful? Did standard form feel not helpful, right? We glance at general form and we know slope, we know y-intercept. We glance at factored form and we know slope, we know x-intercept. General form, though, doesn't easily reveal its characteristics, does it? So let's take a look at general form and see what we can do for finding those things. So if I have ax plus by equals c, how do you find the slope? How do you find the x-intercept? How do you find the y-intercept? Well, turn it into one of the other forms. Let's get the y alone so that we can find all of our characteristics. So let's get the y all alone on his own. So by is cool where he is, but I don't want the ax over there with him. So I'm going to subtract my ax, but if you do it to one side, you must do it to the other. So ax minus ax cancels out. I still have my by. Only now I have these guys on the same side and they are not like terms. I can't combine them. So I'm going to put my x in front. So negative ax plus c. Hooray. So that's good, except my y isn't alone yet. I don't want b times y, I just want y. So I'm gonna, since it's multiplication, I'm gonna divide by b, and that means everybody gets divided by b. That's how it goes. So by divided by b, the b's cancel, and I just have y equals negative a over b x plus c over b. And now I can definitely find some things. Check it out. This is totally general form. So I can see that my slope is negative a over b. So if you're looking at standard form, you can do a divided by b, change the sign, and you're good to go. But my y-intercept is hanging out here too, right? So my y-intercept, just hanging out on the end, is c over b. So that's convenient. So again, if you're looking at your standard form and you're like, what's my y-intercept? You can do c divided by b, and there's your y-intercept. However, the x-intercept still eludes us. But do you remember that factored form gives you your x-intercept? Yes, it does. So here's what we're going to do. Let's divide out our slope. Oh, my pen, that's no good. Don't do that, Mr. Pen. Let's divide out our slopes in order to put it in factored form. So this means I get y equals, and my slope's going to go out in front. We're factoring out our slopes by dividing it out. So negative a over b divided by negative a over b cancels out. This is where it gets messy. I'm going to grab another color for just a moment here. This is where it gets messy. So remember how we did this before. We said you do c over b, but instead of dividing, we multiply by the reciprocal, still negative, but the reciprocal of a over b is b over a. So instead of negative a over b, it's now negative b over a. And check it out, the b's, I got a b on top, b on bottom, they cancel. So it looks like I get negative c over a. So this becomes, oops, let me get my pen back. So I have x minus c over a. Oh, look, and now it's in factored form. Here's my slope, and the guy after my minus sign is my x-intercept. So my x-intercept ends up being c over a. Remember, I don't take the minus sign with me. That in factored form, the minus sign points toward my x-intercept. Excellent. But standard form is rough, isn't it, right? I mean, that means the standard form, like I have to do a little math to find my slope, my y-intercept, my x-intercept. Standard form doesn't just be like, bleh, there's your slope, there's your x-intercept, there's your y-intercept. You have to kind of like work it a little bit. It's rough. So here's the deal. Which forms are best then, right? Like which forms would you rather use to find each of these? So which form would you like to use to find the slope? Which form would you like to use to find the x-intercept? Which form would you like to use to find the y-intercept? Go ahead and just write down which forms you think are best for finding each of these, and then hit play when you're ready to check your work. So I find for slope that there's actually two forms that work really well for slope. Remember that general form looked like this. And I'm just going to make quick notes here. Factored form looked like this. And of course, standard form looked like this. Y equals C. Oh my gosh, I can't even write. That's no good. Both general form and factored form give us our slope. So you know what? Either of those would be great for finding your slope. For the x-intercept, the easiest one is definitely factored form. Remember that negative pointing toward the c, that gives us our x-intercept. So factored form is great for the x-intercept. And for our y-intercept, clearly general form's the good one, right? General form has that y-intercept hanging off the end. So unfortunately, standard form, I mean, we need to know standard form. I get it. And I like that standard form doesn't do fractions. I mean, that's a bonus. But the disadvantage of standard form is that it doesn't easily let us find any of these pieces, does it? That general form or factored form is usually better for finding these guys. It's not that you can't find the others. It's just not as easy in standard form. So here's the other thought. If you wanted to graph an equation using your graphing calculator, think of this as when we go to Desmos, like when you use Desmos, right, and go online. If you wanted to graph an equation on Desmos on a graphing calculator, which form would be easier to type up and to put onto Desmos? Which one would work best for that? Go ahead and hit pause, just jot down which forms you think would work nice with that, and and then hit play when you're ready to check your work. So I don't know about you, but I noticed that on Desmos and on just most scientific calculators, they usually have it as y equals your equation. So that means that general form or factored form would be the easiest ones to use. They would definitely be the most efficient ones to use on a graphing calculator. Some graphing calculators won't even let you put standard form on there because it has y equals built into it. Well, but standard form doesn't do y equals, so it's a pain. It's a pain. So generally, when you're using a graphing calculator, it's better to use general form or factored form. Wow. I feel like standard form just isn't winning any of our competitions here. Poor standard form. We should still give it some love, though. So moving on, let's talk more about these literal equations. We're on activity 2.2 on page 113. Let's talk about literal equations. Literal equations are equations in which the variables represent specific measures, okay? It's not just a variable to be a variable. No, it represents some specific measurement in real life, okay? That's why they're literal equations. It's literally real life here, people, real life. You most often see literal equations when you study formulas. These literal equations can then be manipulated in order to allow you to solve for a specific variable, okay? Like, you know how to find the area of a rectangle, length times width, right? Base times height. You know that. That's a literal equation. My length and my width represent some measurement in the real world. But what we're now saying is that we can manipulate that literal equation. Area equals length times width, A equals LW. But what if I just want the L? Or what if I just want the W? Then we need to manipulate our equations a little bit. And that is the big thing that we're doing today. And that's the big thing that's going to be going on with your homework as well coming up. So here's the deal. You have used a common literal equation all the time. The formula for converting from degrees Fahrenheit to degrees Celsius. Again, I use it all the time. Used to live in Australia, still have a lot of friends back there, and it sounds dumb, but the number of times we talk and we're like, oh, it's a nice day. And they're like, oh, how warm is it? And suddenly I'm having to do conversions from Fahrenheit to Celsius. And so I use this formula quite a bit. I take whatever the temperature is here in lovely Carmel, I plug it into my formula, and I figure out the temperature in degrees Celsius so that I can tell my friends, because if I tell them that it is 80 degrees, they start freaking out, because 80 degrees Celsius means that we maybe shouldn't still be alive. It would kind of be dying and roasting. So I do use this equation quite a bit. So here's the problem. Josh, having a similar issue. I feel you, Josh. I feel you. Josh is talking on the phone to his friend Greg, who lives in Europe. Europeans also use Celsius. They also use the metric system. So Greg is used to describing temperatures in degrees Celsius. That's what they use in Europe. While Josh, if you live here in the US, is used to describing temperatures in degrees Fahrenheit. Problem. It's a problem. Trust me, the struggle is real. Greg can use this formula up above. So Greg, who lives in Europe, he's got his formula, and Greg can use this formula up above to quickly convert the temperatures Josh describes to degrees Celsius. So when Josh is like, oh yeah, it's a warm day, it's like 90 degrees, it's hot, Greg can plug in that 90 degrees and figure out what it is in degrees Celsius so that he knows what Josh is talking about. Josh, though, can't use the formula as effectively, right? Because we need to figure out how Josh can rewrite this formula so that he can quickly convert the temperatures that Greg describes to degrees Fahrenheit. So Greg has a nice little C equals formula, but Josh wants his formula to be F equals. So can you do some work on this formula and solve for F? Can you get the F all alone? I know I'm going to show you, I'm going to show you in just a moment, but if you would like to take a second to just try it out, see if you can get the F alone, go ahead and hit pause, see if you can get an F equals equation, and then hit play when you're ready to check your work. All right, let's get the F alone. There are a lot of ways of doing this. I'm not going to lie, though. I'm hating this fraction. We've been talking in the past, though, about how you can get rid of a fraction. And actually, let me put my big line. I need my big line. You can get rid of a fraction by multiplying by the reciprocal. So fine. The reciprocal of 5/9 is 9/5. But if you do it to one side, you must do it to the other. So I'm going to go ahead and do this. So this means I end up with 9/5 C equals, the 5s cancel out, the 9s cancel out, equals F minus 32. I need to get the F all alone on his own. I don't want him there. And that's a minus 32. So we undo a minus 32 by adding 32. And if you do it to one side, you must do it to the other. Those cancel, which is why we did it. Now, these are not like terms. This 9/5 has a C on it, and that 32 does not. So I cannot combine them. So I'm just going to write 9/5 C plus 32 equals F. Oh, check it out. We got an F equals formula. F equals 9/5 C plus 32. So now Josh can do conversions as well. So when Greg says, oh, it's a beautiful day, it's 25 degrees outside. Now to us, 25 sounds terribly cold. But remember, Greg's in Europe. He's using Celsius. So that means Josh can plug in that 25, work it out, and find out that it actually is a beautiful, lovely day in Europe. And poor Greg is not freezing to death. So now Josh has a formula that he can use too. So here's the deal. I'm going to make you think a little bit now. Are you ready? Josh tells Greg that the temperature where he lives is currently 77 degrees Fahrenheit. Pretty nice day. Greg tells Josh that the temperature where he lives is currently 30 degrees Fahrenheit. Not 30 degrees Fahrenheit, 30 degrees Celsius. Oh my goodness. Josh says it's warmer where he lives, and Greg says it's warmer where he lives. Who's correct? And can you tell me how you got there? Can you tell me why? Go ahead and hit pause. Do a little bit of work here. See if you can figure out where it's warmer. And then hit play when you're ready to check your work. All right, let's see what we can do. Let's use Josh's formula. We got this new formula going, right? I know 77 degrees Fahrenheit. Like, I know that that's a pretty nice day. Maybe a touch warm, but that's a nice day if there's 77 degrees Fahrenheit. So let's figure out what this 30 degrees Celsius is. Let's plug that in. So I'm going to plug that into Josh's formula here. Oh my goodness. This pen. There we go. So we've got 9/5 times 30 plus 32. Remember the trick. You multiply the top first, and then we divide out the bottom. So I need a calculator. 9 times 30 is 270. But we're going to divide out that 5. So 270 divided by 5 gives us 54. And of course, last but not least, we have to add on that 32. So it looks like, it's 86 degrees Fahrenheit where Greg is, isn't it? Oh my goodness. So it's 77 degrees Fahrenheit where Josh is, but it's 86 degrees Fahrenheit where Greg is. Sure enough, Greg is correct. Let me erase all of this off my slide so that we can see a little better. So yeah, it's 77 degrees where Josh lives and 86 degrees where Greg lives. So Greg is correct. It's warmer where Greg is right now. Definitely. Not by a ton, but it is warmer. Can make a difference. All right, so here we go. Were you having trouble converting your Celsius to Fahrenheit? Were you having a little trouble taking your C equals formula and making it into an F equals formula? So Maya, Sherry, and Brian were doing the same work we were doing. They were trying to convert, so instead of C equals, they were trying to solve for F and make it F equals. And some of them did okay, and some of them had some trouble. And some of these problems that they had are very similar to problems I see you guys have all the time. So here's what I would like you to do. Let's start off with A. Let's look at Maya's work, because as I look at Maya's work, I can see that Maya ended up with the exact same formula we did. Maya did a good job. So can you explain Maya's process? Can you take a look through this and tell me what she did, like what her steps were? Go ahead and hit pause, jot down Maya's steps. She did the work, but you got to tell me the steps, and then hit play when you're ready to check. All right, let's look at Maya's work. What did she do? We got rid of the 5/9, but Maya didn't do that. It looks like she got rid of the parentheses by distributing that 5/9, didn't she? Ooh, clever girl. So Maya distributed the 5/9 to the F, so she got 5/9 F, and she also distributed it to the 32. 5 times 32 is 160, And then she just left the 9 on the bottom, didn't worry about dividing that out. So good for her. But now they both have 9s on the bottom, and Maya, I don't think, likes fractions very much, which is fair. Many people don't. So she multiplied both sides by 9, which was clever to make those go away. So it looks like she then multiplied both sides by 9. Good call, good call. So now we have 9c, and now these 9s all cancel out, which is nice. It makes things better. So she just have 5f minus 160. It looks like she then added 160 to both sides, right? So if we do plus 160 plus 160, you get 9c plus 160, and those cancel out. So we have 5f. So she then added 160 to both sides. Don't forget, we're just explaining her work over here. And in order to get the f alone, she divided everything by 5. So divide by 5, those cancel. Divide by 5 gives us 32, and she just left that as a fraction. So she finished off isolating f by dividing by 5. Good. She did some good work. It's not the same method we used, right? She used a different method than we did, but she still got the same answer, and she still did some good work. And we know it's okay to use different methods. We've already learned that. That's fine. Now let's take a look at Sherry. Sherry started off with what we did, but when she got her f all alone, oh my, Sherry's equation doesn't look right. It doesn't look like the one we got. It doesn't look like the one Maya got. I think Sherry made a mistake here. So can you take a look at this and see where Sherry made the mistake? What was Sherry's mistake? What'd she do wrong? And explain it to us. Go ahead and hit pause, jot it down, and then hit play when you're ready to check your work. So it looks like the parentheses disappeared, like she should have factored, but it looks like she only distributed to the f. She did not distribute to the 32. Oh no! So Sherry's error occurs in the second line. She forgot to distribute the 5/9 to the 32. Sorry, Sherry. That's an easy mistake to make, isn't it? Have you forgotten to distribute all the way across before? I know I have. I totally have. So watch out for that. Be careful. All right, same idea with Brian. He started off with the same equation the rest of us had, but his final answer doesn't look right. His final answer does not look like it's supposed to. So again, explain the error in Brian's work. Go ahead and hit pause, jot down the problem, and then hit play when you're ready to check your work. All right, what's going on, Brian? What's going on? It looks like he distributed well. So good. So he didn't make the mistake Sherry did. He did distribute quite nicely. That's good. So 5/9 f minus 160 over 9. Maya did the same thing. Good on you, Brian. It looks like his next step was that he multiplied both sides by 9 to get rid of the fractions. Good call, Brian. Good call. We know that's what Maya did as well. So he distributed, so those canceled out. He didn't distribute right. Check it out. 9 times 5 is 45, but he forgot to divide out the 9. That's bad. And he did it again over here. 9 times 160 is 1,440, but he forgot to divide out the 9. Oh, Brian. So it looks like the error is on the 4th line. These should have canceled out to give us 5f minus 160, but instead he just multiplied by the tops and pretended like the divide by 9 wasn't there. Have you done that before? I've done it before. I'm just saying it happens. So he didn't distribute the 9 to the 5/9 f and to the negative 169 over 9. He just multiplied wrong. So dang, that's rough. That's rough, Brian. That's rough. Poor Brian. It's all good. So there are a lot of mistakes happening here. Well. So let's talk about another way that somebody tackled it. So Carlos and Mikala, they do not like working with fractions. Can you relate? I think some of you can. So they each rewrote the equation so that it does not have fractions, and they've shown their work here. So we've got Carlos on the left, Mikala on the right. But they got two slightly different equations for their answers. So the question is, who's right and why? Hit pause, figure that out, and then hit play when you're ready to check your work. So let's see what's going on here. It looks like Carlos started by multiplying everything by 5 to make the fractions go away. Fair enough. And then he subtracted 9c. Good job, Carlos. That's not terrible. So Carlos's work looks pretty good to me. It looks like Mikala started with a different equation, didn't she? So Mikala started with the C equals equation instead of the F equals equation. So she multiplied by 9 to make all the fractions go away, distributed the 5, and then subtracted 5F. So it looks like Carlos has a positive 5F, a negative 9C, and a positive 160. And Mikala has a positive 9C, a negative 5F, and a negative 160. But they both did it right. They are both correct. These equations are actually equivalent equations because you could multiply everything by a negative 1 on Carlos's equation and get Mikala's equation. Or you could multiply everything on Mikala's equation by a negative 1 and get Carlos's equation. Yeah. So they're both right. Good job, guys. Good job. So I do want to just point out a few little things. These aren't as hugely important, but in the original equations, that whole 9/5, 5/9, the 32, they had meanings of our temperature. Like 32 degrees Fahrenheit is the freezing point of water. You know that? Do you know that? Yeah. And of course, the 9/5, the 5/9, those were our slopes, all that stuff. But with Carlos and Mikala, that 32 kind of disappeared and they didn't have fractions anymore. They still had the 9 and the 5, but they now had a 160. So what are these? Well, the 9 and the 5 are still somewhat important. Now, it was easier when they were fractions, but here's the deal. That 9 and that 5 means that every change of 9 degrees Fahrenheit is equal to a 5 degrees Celsius change. I'm just saying. If it goes up by 9 degrees Fahrenheit, then it only goes up 5 degrees Celsius. That's the truth. And that 160 kind of doesn't represent anything. That 160 is not an important temperature, right? In Fahrenheit, water does not boil at 160. In Celsius, water boils at 100, not 160. In Fahrenheit, water boils at 212. So that 160 kind of doesn't represent an important temperature. Just saying. Poor guy. One last little thing I want you to tackle. Last one, I promise. How is the literal equation y equals a times the sum of bx and c similar to the equation for converting from Fahrenheit to Celsius? How is it similar? And the last thing is, how would you solve this equation for x? Can you get x all alone? So first, two questions. First of all, how is this similar to our Fahrenheit Celsius conversion stuff? And second of all, can you get the x all alone? Can you solve it for x? Go ahead and hit pause. Try this out. It's okay if you get it wrong. Just try it out and then hit play when you're ready to check your work and get a little help. So first of all, we had, what were our equations? F equals 9/5 C plus 32. But then we also had C equals 5/9 times F minus 32. So I want to know how it's similar to this equation. It does have some similarities. Check it out. I've got a slope out in front. I have stuff in the parentheses there. This has a factored form kind of feel to it, doesn't it? They both do. So they have the same structure of that whole constant being multiplied by two terms. They definitely have that factored form vibe going on. So let's answer the second question. How would we solve for x? Let's solve for x, shall we? So let's see what we can do. I need to get x all alone on his own. So the first thing I'm going to do is I'm going to distribute that a. Get rid of those parentheses. So I now have ay equals abx plus ac. A times bx is abx. A times c is ac, although that does not look like a c. That's some bad handwriting there. I'll fix that. It's better. Beautiful, lovely, wonderful. Ooh, but I want to get the x all alone. Ooh, we should make our line. Let's make our line. I want to get the x all alone. So these guys are stuck on pretty good. So let's take care of this dangly guy first. That plus ac, let's get rid of it by subtracting ac. And if you do it to one side, you must do it to the other. So I now have y minus ac equals abx, because those cancel out, which is why we did it. Still need to get x alone, but it's being multiplied by ab. So I think I need to divide everybody by ab. Divide them all. Divide them all. We undo multiplication with division. So those cancel out, which is why we did it. So I have x equals y divided by ab minus, ooh, the a's cancel out. The a's cancel out. So if y over ab minus c over b. In fact, let me write it prettier than that. Y over ab minus c over b. Well, that's beautiful. It's not beautiful. It's kind of funky looking. That's okay. I still love it. It still works. It still does the job. We got x alone. That's all that matters. That's all that we needed. Whew, are you done with this mess? Good. As always, I hope you found this helpful. I hope you found this useful. I know it was a little long, but there was a lot going on there, wasn't there? And of course, if you have questions, ask me. Talk to me during class. Talk to me after class. Talk to me during office hours. Come see me, and I can totally help you out. It's part of the job. So again, hope this was helpful. Hope this was useful, and I'll talk to you later. Bye.